Hello, this is Team 6, and we are doing the Natural Language Processing project. The title of our project is Diagnosing Heart Failure with Natural Language Processing and Artificial Neural Networks. A little background. Heart failure is a leading cause of death throughout the world, and particularly in the United States. As many as 650,000 cases are diagnosed yearly, but prevention is possible. Early diagnosis of heart failure or recognition of heart failure symptoms could lead to improved health in the vast number of individuals who suffer from heart failure. Much research has been done in using artificial neural networks and machine learning methods for disease diagnosis and patient phenotyping. And there is a large quantity of available data to use for diagnosis in the unstructured doctor notes that make up electronic health records. Many methods for performing such tasks involve natural language processing to extract information from the wealth of information available in electronic health records. Often, these methods rely on concept extraction techniques, identifying certain terms or medical jargon in the data. While some tools exist for automatic concept extraction, much of the work to process or annotate the data is still done by medical experts. Our research focuses on eliminating the need for human intervention by using machine learning models capable of learning from this raw data to increase the efficiency and accuracy of patient diagnosis. We will use tools such as Spark and neural networks to process this vast quantity of data. The data used for our research comes from the Medical Information Mart for Intensive Care, also known as the MIMIC-3 database. This database includes de-identified information on patient visits to the ICU. The data relevant to this work includes patient diagnoses in the form of international classification of disease codes and hospital discharge summaries. We identified 41,127 patients that had a discharge summary available for natural language processing. Labels were determined by a 428.x ICD-9 code given at the hospital admission corresponding to the discharge summary. These ICD-9 codes correspond to a heart failure diagnosis. We used PySpark and the Python package NLTK to perform ETL processes to get the data into a format we could use in our models. We then built our models using PyTorch and learned from a variety of different extracted features. Several approaches were used to extract features from the textual notes, which were in turn used to train the models. The approaches used were bag of words, bigrams, and term frequency inverse document frequency. Each approach yielded a large number of unique features, even after removing stop words and lemmatizing the words in the text. For the bag of words approach, there were 424,654 unique tokens. Bigrams yielded 3,213,402 unique features, and TF-IDF, or term frequency inverse document frequency, included 183,608 features. For the modeling portion, we used a multi-layer perceptron, a convolutional neural net, and a recurrent neural network to model the natural language data that we had. Here you can see a table of the results we obtained using our various models. The highest performing model was the bag of words extraction technique combined with a convolutional neural network. So, in conclusion, our experiments further validate the usefulness of deep learning approaches to modeling raw data and minimizing the need for pre-processing data with involvement from medical experts. The hope is that this technology can be applied to the ever growing corpus of electronic health records to ease the administrative burdens on healthcare providers and provide actionable insights that improve medical care and patient outcomes. We expect that by combining the findings from our research with information extracted using established methods, including temporal data and diagnoses codes, will provide the best performance for early diagnosis of heart failure. Thank you.